Hey everybody, this is Todd Hendricks. I am sharing my notebook with you here and walking you through just a couple of points, high points of my notebook. My name is Todd Hendricks. I work for the Legal Defense Fund, which is one of the oldest, or is the oldest civil rights organization in the United States. My presentation was about the Voting Rights Act of 1965. Unfortunately, in the United States, there is a history of governments, state or local governments, using election laws to discriminate against minorities. And President Johnson passed the Voting Rights Act of 1965 as a means to make sure that everybody has an opportunity to elect their candidates of choice. Under Section 2 of the Voting Rights Act, there's a body of law that I talk about here, but basically that section of the law provides the framework for what we're about to look at today in my notebook. So the analysis that I produce, the output of that analysis speaks directly to the liability concerns of a Voting Rights Act claim. And basically, if I can prove through my inference that racially polarized voting exists, that's a big step towards moving forward in a lawsuit. And so that's how I spend my time. Again, not to get too much into the legal stuff, but the racially polarized voting is a legal doctrine under the broader legal doctrine of minority vote dilution, which rolls up to Section 2 of the Voting Rights Act of 1965. I just throw all that stuff out just to, if you want to Google it and look. But we're not here to talk about the law. We're here to talk about PyMC. And I'll just note in my import cell here a couple of things here. So the only thing you have to do in order to get going with this is import PyEI. And what PyEI is a library developed by Dr. Moon Duchin and Dr. Karen Knudsen at Tufts University. They have a laboratory called the Metric Geometry and Gerrymandering Group, which basically they build a lot of really helpful Python packages to help people like me that are working with lawyers to produce empirical information. So that's what PyEI is. Of course, it's built on PyMC, which is why we're here today. And yeah, I think that covers everything. I'll just note, I think you might run into an error if you don't have this line. I think this has something to do with the Google Colab runtime, but all I know is it works, so you might want to keep that in here. So this notebook is an example of what I would show to a lawyer. What we're ultimately going to get to estimates of posterior distributions that I would that would inform how I speak to a lawyer about racially polarized voting. So the data we have here is a local election from Santa Clara, California. I speak to the nature of the inputs and do some EDA. Basically, there's really three components that are really important to fit an RPV model. The first is you have to have at a precinct level, and a precinct, by the way, is lowest or the most granular political geospatial unit that the government keeps data for. And often it's the case, at least within census data, you'll have population values for each racial group. And what we're doing here basically is we're producing a column or a vector of floats that represent the percentage of each of these racial groups. And we're storing that in a NumPy matrix as group fractions R by C. We're doing the same thing for the candidate percentages. And so each of these here, we have 3 candidates. We have Hardy, we have Kolstad, and we have Nadim in this particular election. And these percentages are how much of the total votes cast was cast for Hardy in the same precinct as these. And so, we have another matrix of floats for vote fractions. And ultimately, in big picture here, ultimately what we're trying to do is we're trying to get a sense of, for each racial group, what were their preferences among the candidates? For the Indian vote, we're going to see how did they like Hardy? How did they like Kolstad? How did they like Nadim? And when we get to those, when we're able to characterize those preferences, that gets us to a place where we can actually talk about racial polarization. Because if one racial group is all in for one candidate and another group is basically all against that candidate, that's where you get polarization. Think about the separation, and we'll get to that in a minute, but this statistical characterization is really trying to characterize really the degree of antagonism between groups that have different preferences. So I instantiate an object. This is the object we're using to fit the model here. It is a PyEI model that calls the PyMC backend. And you can see the different variables I'm adding when I call fit. Excuse me. And I'll just make a note here. We have 42 precincts in Santa Clara here. One of the challenges I run into is, our data sets are typically pretty small, particularly for local elections. We're not, very seldom do I have more than 100 rows. In this one, I have 42. Excuse me. And for those who have fit a lot of models, that's not a lot, right? I mean, that doesn't give your sampler a lot to work with, and often as a result, it's difficult to fit these models when I don't have many rows, and so my sampler will fail. Fortunately, I'm using toy data that's been cleaned, so we can see that my chains ran just fine. I'm not getting yelled at by my sampler, so everything's good. I did want to just demonstrate quickly that the model that we're fitting is a hierarchical model. You can take a look at its design here. And to conclude this video, I just want to talk a bit about how do we interpret the results? What are the results we get, and how do we interpret those results? And really the meat of it is in this, when I call summary here, it prints out a long string here. And let's take a look at what it's saying. So because we have 3 candidates and 3 racial groups, and we want to see how each candidate fares with each racial group, that gets us to 9 different posterior distributions that we need to estimate. And we have 9 floats here. So what we have here is basically what we need. Let's take a look at this first row. What we know from this first 3 rows here are that 13% of the Indian population that cast a vote in this election supported Hardie. And from this 13%, we also get a credible interval that explains or that accompanies the mean. And the next float here says that Kolstad did a little bit better than Hardie, actually. Kolstad got about 16%, whereas Hardie got 13%. But the candidate out of the 3 that did the best among Indian voters is Nadeem. And we can see that Nadeem got pretty much 71%, 706. And we also have the credible interval for that as well. And you can take a look at the results, but ultimately, zooming out, when I'm communicating to a lawyer, what I would say was, hey, we can be pretty confident that, at least based on these values, that the Indian population in Santa Clara really liked Nadeem. He was clearly their candidate of choice. And we can kind of go in the different groups here, but I'll leave that to you. The last thing I'll say here is, looking at floats is fine, but what I really love about this PyEI package is the plotting functions that Dr. Duchin and Dr. Knudsen have built in to accompany the PyMC. They're calling on matplotlib objects. And with these objects, we can really see the information that we got here with just much better clarity. So, I mentioned the Indian population a second ago, and I said, hey, we can be pretty clear that, they really liked Nadeem. But when you look at this last subplot here, you can see that the credible interval is actually very wide. And so I mentioned that, he got about 70% of the Indian vote, but actually that's a very wide credible interval. And, that tells us that we've got a very wide posterior, and, we don't have a lot of ground to stand on as far as 70% goes. That doesn't tell us very much. We don't have a lot of confidence in that number. On the flip side, we know that the non-voting, the non-Asian voting population here, we can be very confident that they weren't that crazy about Nadeem, right? Because they've got, the credible interval is very narrow, right around 30%. And, in this particular instance, I know that these wide credible intervals are just the result of the population numbers being pretty small. The non-Asian populations at the precinct level are probably much more significant than the other Asian populations. This is probably about 80%. Non-Asians are probably 80% of Santa Clara, is my guess. But hey, you can play with that if you want to. And And I do talk about a little bit more about interpretation in the notebook. Um, the key things that I look at on these plots, and I kind of have already gone over this, are the the difference, or basically the gap in between these ridges, which corresponds directly with the notion of racial polarization. Um, Again, for Hardy, we can see that non-Asians and Eastern Asians, there's a big gap in between them. So we would say that those two groups are polarized. And the same could be said for Nadim, the Indian population. Even though we have a wide credible interval, it's pretty. There's a significant kind of difference between Nadim's support among Indians and his support among the East Asians, however those are defined. So the gap in between these ridges are important, and then the gap within the ridges are important because that conveys the degree of confidence that we can have in our measure of central tendency, which is the mean of the posterior. You can play with a couple of the different plotting functions here. It's all showing the same thing. And yeah, that's the notebook. I'm really glad that you were able to take a few minutes to look at it. Please let me know if you have any questions. And just to conclude, I'll just note that race is obviously a fraught topic in American life, and it's tricky to talk about. But really, what this analysis does, it's an input to a larger process where we all have different opinions, but what counts is making every vote count. And really, what we want to do is protect the integrity of our democratic process through this analysis. And it's not about who wins; it's just making sure that everybody feels good about the process. So that's really the motivation behind this analysis. And again, thanks for taking the time to look.